Assalamualaikum and hello everyone. My name is Muhammad AIZAT bin JUFRI and I will do the question 5 for the assignment in dynamic. So the question 5 asks the 50 kg box is pulled by the constant force P as shown in figure 5. The box starts from rest and achieve a speed of 10 meter per second in 5 seconds after moving for 25 meter. The coefficient of kinetic friction between the crate and the floor is nu k equal to 0.2 and angle is 60 degree. Neglect the size and shape of the box. Compute the magnitude of force P and the normal reaction on the crate. So the question asks to identify the magnitude of force P and the normal reaction on the crate. So this is the answer for question 5. The first step we need to do is do the free body diagram. From the given figures, we can draw the FB diagram like this. This is the force P. This is the neutral normal reaction, and this is the W, which is mass times gravity. 50 times 9.81 and we can get the answer is 490.5 Newton, and this is the force equal to nu k times n. N is the normal reaction, so the answer is 0.2 n. And then we have the acceleration, which is acting toward the left because the box is pulled to the left. So what we can get from the equation is V0 is equal to 0 meter per second, V1 is 10 meter per second, S equal to 25 meter, T is 5 second, nu k is 0.2 and angle is 60 degree. After that, we identify the acceleration by using the kinematic equation, which is V square is equal to V naught square plus 2 AC times S minus S naught. So we solve the kinematic equation by using this data, and we can get the acceleration is equal to 2 meter per second squared. After we get the acceleration, we need to find the magnitude of force acting on P. So the formula that we can use is, first, the summation force acting on y axis. So we can get the equation by look at the FBD diagram. Regarding the FBD diagram, the force that acting on y axis is W, N and P. So the equation is P sin 60 degree minus 490.5 plus N is equal to 0. So we can get the equation N is equal to 490.5 minus P 0.866. So we have the two unknown, so I make it as equation 1. So after that, we use the summation force acting on x-axis, which is equal to MA. The force acting on the y-axis is F and P. So the equation is negative P cos 60 degree plus 0.2 N is equal to 50 times negative 2. So negative P is because the acting on the left, same like negative 2 because the acceleration is acting on the left, and 0.2 N is acting on the right. So we solve the equation and we can get the equation negative P 0.5 plus 0.2 N equal to negative 100. So I make it as the equation 2. So we need to substitute from the equation 1 into the equation 2, and we can get the answer of P. So the P is equal to 294.266 Newton. So this is the answer for A, which is we need to identify the magnitude of force P. So this is the answer. And the second question, he asked to find the normal reaction on the crate. So we may know that N is the normal reaction on the crate. So by solving the equation 1, we can get the normal reaction on the crate. So the N is equal to 235.666 Newton. So that's all for now. Thank you.
Number 9. The double pulley shown in figure 9 consists of two wheels which are attached to one another and turn at the same rate. The pulley has a mass of 10 kg and radius of gyration is 0.1 meter. The block A has a mass of 30 kg and is initially at rest. A constant force is equal to 3 kN is applied to the rope wrapped around the inner hub of the pulley. In 5 seconds after F is applied, A. Determine the angular velocity of the pulley. B. Solve for the speed of the block. This is the solution for the question. First, we draw the free body diagram and draw the kinematic diagram. Then we come out the equation to solve the problem. H0 plus moment equal to H0 2. We assume the direction of clockwise is positive, and we come out the numbers. H0 is 0 because it at rest, and the moment is this 3000 times 0.075 times 5 seconds minus this 30 kg times 9.81 times 0.2 and times 5 seconds. Then equal to H02, which is IMK square times omega plus MVR. We insert the numbers. 10 is the mass of the pulley times 0.1. 0.1 is radius of gyration square times omega plus 30 kg times 0.2 omega times R 0.2. So we come out we get the answer 830.7 equal to 1.3 omega. Then omega equal to 639 rad per second. Then we can get the velocity at A. Velocity equal to omega R. R is 0.2. 0.2 times 639 the omega. We get the answer is 127.8 meter per second. Thank you.